Hello, today I'm excited to present to you a reinforcement learning algorithm to resolve educational inequality. By using this algorithm, we want to help solve the two sustainable development goals of the UN. The first one is to achieve quality education, which ensures inclusive and equitable quality education and promote lifelong learning opportunities for all. The second one is reduced inequalities, which reduces inequality in the education field across genders, countries, race, creed, etc. The main problems we want to solve are lack of educational infrastructure and resources, discrimination, marginalization, and socio-economic disparities, and geographic inequalities. Our goal is to create a personalized learning recommendation system using reinforcement learning. First, let's briefly discuss the personalized learning in education. Personalized learning, also known as individualized learning or adaptive learning, is an educational approach that tailors the instruction, pace, and content to meet unique needs, preferences, and interests of each learner. It recognizes that students have different learning styles, strengths, weaknesses, and backgrounds, and aims to provide customized learning experiences to optimize their educational outcomes. By providing personalized learning experiences, we can enhance students' engagement, comprehension, and overall academic success. The reinforcement algorithm helps in resolving the problem of inequality in education by recommending the best action that needs to be taken by the students who are in their respective circumstances and help the students acquire quality education and also reduce inequality, thereby addressing the Sustainable Development Goal 4 and 10. Now I will talk about the steps for implementing the whole process. The first step is the data collection. Data can be collected from the students directly and also from the databases of government agencies, nonprofit organizations, research institutions, and parents. The second step is parameter optimization. We will choose the parameters that result in the best performance for the chosen metric. The third step is implementation of the algorithm. The Q-learning algorithm is updated on the defined states and actions to give the best action that needs to be taken by the new student. And then the algorithm best action for the new student. The new input is informed of the best suitable action that can be taken in order to progress towards obtaining educational equality. The algorithm is based on the states and actions that are relevant in solving the issues that our students are facing. So the states that are selected to train the Q-learning model include socio-economic disadvantages, economic inequality, racial discrimination, gender disparity, geographic disadvantage, disability discrimination, language barriers, cultural bias in education, lack of quality teachers and educational infrastructure, unequal funding for schools, digital divide, and so on. The actions include investing in targeted socio-economic support programs, improving access to educational resources such as books, computers, and internet, implementing policies to reduce income inequality, promoting diversity and inclusion in educational institutions, develop educational programs tailored to different geographic regions, ensuring accessibility and accommodations for students with disabilities, providing language support and bilingual education programs, addressing cultural biases in curriculum and teaching methods, recruiting and retaining qualified teachers and improving school facilities, reforming educational policies to promote equity and fairness, equitably distributing funding to schools based on need, and etc. So the results are based on the rewards obtained from the algorithm in the training process. We can see in this graph there are some fluctuations, and this may result from the system's and experimentation phase. During the training, the system may explore different learning strategies, leading to fluctuations in learning progress as it identifies effective approaches. And the fluctuations indicate the system's adaptability to individual student needs. The system may adjust its recommendations based on real-time feedback and students' responses, leading to fluctuations as it fine-tunes its approach. And the fluctuations may also reflect students' responses to challenges or obstacles in the learning process. Students may encounter difficulties understanding certain concepts or may experience variations in motivation and engagement, resulting in fluctuation. And the fluctuation may decrease over time as the system optimizes its recommendations and learning strategies. As you see, the fluctuations are increasing. It shows the system learns from past experiences and refines its approach. So the fluctuations may become less pronounced, leading to smoother learning trajectories. And you can also see a rising trend in the average reward. It suggests that, on average, students are experiencing greater success or achieving better outcomes over time. This could mean that the personalized learning recommender system is effectively guiding students towards actions or strategies that lead to higher rewards, such as improved understanding of concepts, increased engagement, or better performances on assessments. Now I will show you the code. As you can see, based on the states and actions, the learning rate is chosen to be 0.1, which will help in striking a balance between exploring new actions and exploiting known actions. And the best action selection is based on an epsilon greedy policy, with epsilon value to be 0.5. The algorithm then chooses the action with the highest Q value for the current state. Then the Q value is updated using the learning rate to get the next state's action. The algorithm is run for 500 iterations. However, this number of iterations may vary depending on the environment and conditions that we are working on. After running the iterations, the algorithm will recommend the action that has the highest Q value. So in conclusion, the personalized learning recommendation system shows promise in providing tailored recommendations to support students' learning. It has demonstrated the ability to adapt its recommendations based on an individual student's characteristics and preferences. This helps in increasing the outcome-based learning of the students by providing the best suitable actions and ways that students can adopt for their education. Hence, it will help in obtaining quality education and also decrease the inequalities. That's all. Thank you.